Welcome to tonight's video on Unit 9, Part 1, talking about more trigonometric identities. First thing here, we'll talk about the cofunction identities. Those happen in a right triangle when you have an angle and then its complement. The sine of the angle would be b over c. The cosine of the angle would be a over c. The tangent would be b over a. Cosecant would be c over b. Secant would be c over a. And cotangent would be a over b. But if you do the sine of the complement, then that's a over c. The cosine of the complement would be b over c. The tangent of the complement would be a over b. The cosecant of the complement would be c over a. The secant of the complement would be c over b. And the cotangent of the complement would be b over a. So if you look at these in terms of identities, you could say the sine of theta is equal to the cosine of its complement. The cosine of theta is equal to the sine of its complement. The secant of theta is equal to the cosecant of its complement. And the cosecant is equal to the secant of its complement. And the tangent is equal to the cotangent of its complement. And the cotangent is equal to the tangent of the complement. All right, so these cofunction identities will help us to prove what are called sum and difference formulas. So if you notice, you have two angles. You have beta here, and then alpha goes all the way across. So the coordinates here on the unit circle, this would be cosine alpha, sine alpha, and this would be cosine beta, sine beta. And then if you found the distance between the two coordinates, you would have the distance formula. So you'd go the square root of cosine alpha minus cosine beta squared plus sine alpha minus sine beta squared. Then if you square it to get rid of the square root sign, you just get cosine alpha minus cosine beta squared plus sine alpha minus sine beta squared. Then you do the FOIL, so you get cosine squared alpha minus 2 cosine alpha cosine beta plus cosine beta squared. And then the same thing here, plus sine squared alpha minus 2 sine alpha cosine alpha, or cosine beta, sorry, or 2 sine alpha sine beta plus sine squared beta. So notice here you have a couple identities, cosine squared plus sine squared for alpha and beta. So that means you have 2 minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. All right, so that's as far as we can simplify that one. But now if we look at it in terms of one of the angles being in standard position, all right, and then alpha minus beta is just the angle itself. So this would be cosine alpha minus beta, and then sine alpha minus beta as the coordinates. And then this coordinate here would be 1, 0. So when you did the distance, you get cosine alpha minus beta squared minus, or sorry, cosine alpha minus beta minus 1 squared plus sine alpha minus beta squared, because minus 0 is just itself squared. Then when you remove the square root sign, you just get cosine by squaring both sides, you get cosine alpha minus beta minus 1 squared plus sine squared alpha minus beta. Now if you FOIL, you get that cosine squared alpha minus beta minus 2 cosine alpha minus beta plus 1 plus sine squared alpha minus beta. Well, notice cosine squared plus sine squared is 1, so this means that you get 1 plus 1, which is 2, minus 2 cosine alpha minus beta. Now, notice these are both equal to d squared, so I can set them equal to each other. And then when we simplify, I'm just going to zoom in a little bit here to get a better view. Yeah. All right. So when we simplify, notice we get, well, the 2's cancel. And then if I divide by -2, everything. So I get cosine alpha cosine beta plus sine alpha sine beta. That is equal to cosine alpha minus beta. So there's our formula for cosine alpha minus beta. Cosine alpha cosine beta plus sine alpha sine beta. Now, as far as alpha plus beta, that's the same as saying alpha minus negative beta. So if we were to substitute that in, and we'll do it on the next page, using the same formulas. So we have cosine alpha cosine negative beta plus sine alpha sine negative beta. Using the even and odd, that cosine's even, so it means it's cosine alpha cosine beta, but sine is odd. Careful. So that means you're going to take the opposite, sine alpha sine beta. So that would be cosine alpha plus beta, cosine alpha cosine beta minus sine alpha sine beta. So then to do the sine, remember that would be the same as saying alpha minus pi over 2 minus beta. So you have, when you distribute the negative, you're going to have cosine alpha minus pi over 2 plus beta. So that's the same as saying cosine alpha minus pi over 2 cosine beta minus sine pi over alpha minus pi over 2 sine beta. And notice cosine alpha minus pi over 2 is sine alpha. So you have sine alpha cosine beta minus, and this would be cosine alpha sine beta. And the same thing for sine plus alpha, sine alpha plus beta. You could do sine alpha minus negative beta. So it's sine alpha cosine negative beta minus cosine alpha, or sorry, yeah, cosine alpha sine negative beta. So it'd be sine alpha cosine beta, because cosine is even. And then notice, because it's a minus, because the sine is odd, so it's going to turn into a plus. So cosine alpha sine beta. So there are the formulas for sine alpha minus beta. Notice it's sine, cosine, cosine, sine, whereas cosine is cosine, cosine, sine, sine. But notice for the sines, for cosine, the sine is the opposite in the middle of what you are doing. So if you're adding, you're subtracting, addition, whereas sine, it's the same, subtraction, subtraction, addition, addition. This leads us to the double angle formulas, and double angle formulas, maybe it's just adding the same angle. So that means you have sine alpha cosine alpha plus cosine alpha sine alpha, and notice these are the same, so it's 2 sine alpha cosine alpha. For cosine 2 theta, notice you have cosine of alpha plus alpha, so it's cosine alpha cosine alpha minus sine alpha sine alpha. So you get cosine squared minus sine squared. That's one version. If you substitute in like 1 minus sine squared here, so you get 1 minus 2 sine squared. That's another version. And if you substitute in for the sine squared, 1 minus cosine squared, you get 2 cosine squared minus 1. So those are the 3 versions of the double angles. There are also the half angle formulas, which we are not going to derive, but it is important to know that the plus or minus basically talks about what quadrant it's in. So if you're talking about a half angle, and the angle you're taking half of is in the first quadrant, well, half of that means that it would still be in the first quadrant, but now it's just between 0 and pi over 4. So it's in quadrant 1. If it's in the second quadrant, well, half of that is between pi over 4 and pi over 2, so it's still in the first quadrant. If it's in the third quadrant, well, half of that is between pi over 2 and 3 pi over 4, which is now in quadrant 2. And then in the fourth quadrant, half of that is between 3 pi over 4 and pi, which is quadrant 2. So that's basically how you determine what quadrant it's in. You just take half of the boundaries, and that'll tell you what quadrant the half angle is in. All right, so that concludes our video on how to derive them. The next video we'll talk about how to solve the problems. So I'll make that a separate video. Hope everything's going well and you're staying healthy, and I will see you on Zoom.